Today we are working with lesson 1.4, writing equations and inequalities. In the previous section we wrote expressions. Expressions have one major difference of equations and inequalities, and that's that equations have equal signs and inequalities have some sort of inequality symbol. We will be looking at all of those different types today, as well as using what we did in the previous lesson, adding the equal sign and the inequality symbols into it. So your goal for today is that you will be able to translate a verbal sentence into an equation or an inequality. We have several vocabulary words. We have open sentence. This is a mathematical statement that contains two expressions and a symbol that compares them. Specifically, an equation is an open sentence that contains the equal symbol. It's right here. There are four types of inequality symbols that we will learn. An inequality is an open sentence that contains one of those symbols. Less than or equal to, greater than or equal to. And I am going to add to the side what each one of these means. This is the less than symbol. Less than or equal to. Greater than. And then greater than or equal to. We're also going to be working with solutions of equations and inequalities. A solution of an equation is a number that, when substituted for the variable in an equation, results in a true statement. So we're going to be testing things out today, seeing if something is a solution. And of an inequality, that is when a number, when substituted for the variable in an inequality, results in a true statement. So the same thing, you're going to be plugging in a number, seeing if that inequality symbol is placed correctly, making that statement true. Our first box is expressing open sentences. So we're going to be kind of defining what each of these means. I kind of did it up at the top, and we'll kind of be repeating the same information down here. This symbol is the equal sign. A equals B. Okay, A is equal to B. Associated words, A is the same as B. And the next one, my notes are missing the symbols. Your notes may as well. Make sure you add them in if it's not there. This is supposed to be a less than symbol. So we read that A is less than B. And we can say A is fewer than B as an associated word. Our next one is A is less than or equal to B. So we say A is less than or equal to B. Associated words, A is at most B. A is no more than B. Our next one is A is greater than B. A is greater than B. Associated words, A is more than B. And our final one, A is greater than or equal to B. Again, that's A is greater than or equal to B. Associated words, A is at least B. or A is no less than B. On our next page of notes, we're going to take a look at example 1. We are translating an equation or an inequality into that, or we're translating the verbal sentence into that equation or inequality. So we start with the sum of 3 times the number A and 4 is 25. What we want to do is we want to locate the is. In this case, that's going to tell us where the equal sign is. So what we're able to do is we're going to be able to put an equal 25. And we can cross that out because I don't need to look at that anymore. But I see that I'm left with the sum of 3 times the number A. 3 times a number A and 4. So I have two things going on here. I'm going to be adding and I'm going to be multiplying. Well, I'm multiplying the 3 and the A. So that's 3A plus 4. In B, I see I have the is fewer than. Well, is fewer than signals a less than symbol for us, so it's less than 10. Quotient signals division, so we're dividing x and 4. So it's x over 4 is less than 10. In C, this is a compound inequality, so we have two things going on here. We're going to look for a common point. So I'm going to take in red and I'm going to read the one of the two inequalities that's taking place here. N is greater than 6. Okay, that's one of our inequalities. And less than 12. Well, that's actually N is less than 12. So you've got N in two different parts of this compound inequality. N is going to go in the middle. I'm going to start with the blue. N is less than 12. Because that's read the way that we're wanting to write it down. We want the N to go in the middle. We want the number to go on the right side. N is less than 12. But what do I do with the greater than 6? Well, I'm going to look at it backwards as N is greater than 6. Now, if I was to write that with the N first, that's the way it would look. But I want you to note that the open end is towards the end, just like it is here. The open part of the inequality symbol is towards the end. And we call this compound inequality, and it's something that we will revisit much further along in the book in chapter 6. In example 2, we're going to do something that you will see almost every single chapter in your book. And that is checking to see whether something is a solution. In this one, we're specifically checking to see whether 2 is a solution of the equation or inequality. So in A, we have 7x minus 8 equals 9. Well, I'm substituting a 2 in for x. So 7 times 2 minus 8. Is that equal to 9? Well, 7 times 2 is 14. And 14 minus 8 is 6. Is 6 equal to 9? No, they're not equal. So 2 is not a solution. For B, 4 plus 5y is less than 18. We substitute 2 in for the y. 4 plus 5 times 2. 5 times 2 is 10, and 10 plus 4 is 14. Is 14 less than 18? Yes. So 2 is a solution. In C, we're substituting our 2 in for the n, 6n minus 9, and that's supposed to be a greater than or equal to symbol. 6 times 2 is 12, and 12 minus 9 is 3. So is 3 greater than or equal to 2? Yes, it is. It's greater than. So 2 is a solution. Take a moment at this point to try the checkpoint questions on your own. We will be going through them together. Each different problem has a different number that you're substituting in for the variable. So in number 1, 6r plus 1 equals 25. We're going to plug the 4 in for the r. So we have 6 times 4 plus 1 is equal to 25. We're deciding whether that is true or not. Well, 6 times 4 is 24. And 24 plus 1 is 25. And 25 is equal to 25. So we would say this is a solution. In number 2, we substitute a 5 in for the x. So we have 5 squared minus 5 is greater than 10. 5 squared is 25. 25 minus 5 is 20. And is 20 greater than 10? Yes, it is. So this is a solution. Number 3. This is supposed to be a less than or equal to. 7a is less than or equal to 21. We're substituting 6 in for a. So that'd be 7 times 6 is less than or equal to 21. Well, 7 times 6 is 42. Is 42 less than or even equal to 21? No. So this is not a solution. And to our last page. In example 3, we are previewing some of the concepts that we will be covering in chapter 3, and it's solving an equation. But in this section, we're going to just be using mental math, so we're not going to be looking at anything with more than one step at this point. So in A, we have n plus 6 is equal to 11. Now we do have a question here. We're going to think of this as a question. What number plus 6 equals 11? Now, some of you may be able to do this in your head very easily. You may say, I know that 5 plus 6 is equal to 11. Some of you may not know that off the top of your head, and you want to try some things out. If you're going to try things out, make sure that you're using kind of a method. You pick a number, and you know whether you have to go higher or lower, and know what numbers you've picked. Otherwise, you could sit and try things out for a long time. But to check yourself, you put that number back in. 5 plus 6 is equal to 11. In B, we're going to write the question out that we have going on here. We have 18 minus x equals 10. So our question, our thought process is 18 minus what number equals 10? Well, I know that 18 minus 8 is equal to 18 minus 8 is equal to 10. So I substitute the 8 in. And I check that out. 18 minus 8 is 10. For C, 7a equals 56. So the question we ask is 7 times what number equals 56? Well, 7 times 8 is equal to 56. If you try that out, yes, 7 times 8 is 56. And our last example for this one, b divided by 11 equals 3. The question we want to ask ourselves is, what number divided by 11 equals 3? And that would be 33. 33 divided by 11 equals 3. For those of y'all who remember what we did last year when we solved equations, you would remember that to figure this out without having to go through all the steps of just guessing, do the opposite operation. For example, in A you were adding, so subtract. 11 minus 6 is 5. This is a little bit different. Even though it's subtraction, you would still subtract 18 minus 10. Here you would divide in C. You were multiplying, you would do 56 divided by 7. And here, since you were dividing, you would multiply. But to make sure you're successful, always substitute it back in to check your work. And to our last checkpoint, solve the equation using mental math. Again, I would do what we were just talking about in number 4. I see that I'm adding x plus 9 equals 14. So if I do that opposite and subtract, 14 minus 9 is 5. I can try that out. Is 5 plus 9 equal to 14? Yes, so 5 is my answer. 5 is a little bit more complicated because it actually does have 2 steps. If you remember just solving equation, this one shows mental math, but I'm actually going to review with you the method that we did for solving a 2-step equation last year. We drew our line. We start with the minus or the plus. It was minus 4, so we have to do the opposite to both sides and add 4. We didn't do anything with 5t, so it's still there, but that's gone. 11 plus 4 is 15, and then you divide both sides by 5. T equals 3. If you do not want to go through these steps yet, and you want to try numbers out, you're free to try numbers out. Just make sure you check them all. And then finally in number 6, y divided by 4 equals 15. Well, I could do the opposite and multiply. 15 times 4 is 60. So 60 divided by 4 is 15, so that does check out. So my answer is 60. That concludes section 4. Take this time to make sure you have all of your notes, to review any information that may be confusing yet, and tomorrow we will do your assignment in class. Thank you.